Hello guys, welcome to another video of GK. In this video, we will talk about the laws of thermodynamics. Okay? So what is thermodynamics? Thermodynamics is a branch of physics that deals with heat, work, and temperature and the relationship to energy, radiation, and properties of matter. So, thermodynamics is a branch of physics and it deals with the relation between heat, work, temperature, and energy, radiation, and properties of matter. Okay, and we will talk about this in today's video. Thermodynamics is mostly related to transfer of heat and energy. Heat is a form of energy, so you can think mostly related to energy. Okay. It was discovered in 19th century. The first established principle of thermodynamics was formulated by Nicolas Leonard Sadi Carnot. Okay. Contradict to some beliefs, there are four laws of thermodynamics: zeroth law, first law, second law, and third law. So most people think that there are three laws of thermodynamics: first law, second law, and third law. But in real, there are four laws of thermodynamics: zeroth law, first law, second law, and third law. There are four types of thermodynamics: classical, statistical, pure, compound, and solution. We will not talk about the types of thermodynamics in this video. Okay, so as you can see in this picture also, energy, the heat from a hot object is moving towards the cold object. Zeroth law of thermodynamics. Zeroth law of thermodynamics is the basis for the measurement of temperature. So you measure the temperature with a thermometer. Absolutely. Enough? Yes. Okay. So you measure the temperature with a thermometer. So the zeroth law of thermodynamics is the basis for the measurement of temperature. So your thermometer actually uses the zeroth law of thermodynamics. Right? It states that two bodies which are in thermal equilibrium with the third body are in thermal equilibrium with each other. So this means that as you can see in the picture that this is a thermometer and this is object 2 and this is object 3. Okay. So when we measured the temperature of object 2, it was equal to them when we measured the temperature of object 3. Okay. So first of all I will tell the example. For example, if we take 2 cups of A and B and pour normal water in them. So we take 2 cups A and B and pour normal water in them. Normal temperature water. Okay. Then we measure the temperature of cup A with a thermometer. So we measure the temperature of the water in cup A and the reading shows 35 degrees Celsius. This means that the water and the thermometer are in equilibrium with each other. First of all, equilibrium means that have you seen a weighing scale? Type of weighing scale that has like a seesaw. Have you seen a seesaw light? You would have played it in childhood. So, like in a seesaw, if the weight of both the persons on the seesaw, on the two sides of the seesaw is equal, then the seesaw will balance. Yeah, right? Right? So similarly, equilibrium in science means that the objects have something in common, like temperature, which is common, or something. There something is in common. Okay, so there are many types of equilibrium. In this video, we are talking about thermal. Okay. Then we take the reading of cup B, and it also shows 35 degrees Celsius, and so they are in equilibrium. So thermometer and the cup B is also in equilibrium. According to this law, cup A and cup B are also in equilibrium, right? Because when we measure the temperature of cup A with a thermometer, cup A and thermometer were in equilibrium, then we measured the temperature of cup B with the thermometer. A thermometer and a cup B are in equilibrium. So this means that object 2 and object 3 are cup A and cup B are also in equilibrium. Okay. Thus, this law is used to compare the temperature of multiple objects. As you can also see in this picture, the thermometer is used to take the temperature of object 2 and object 3, and as the temperature was same in both, so object 2 and object 3 are also in equilibrium. Okay? First law of thermodynamics. This law is also known as conservation of energy principle. Okay. It states that energy can neither be destroyed or created, but it can be transformed into another form of energy. Okay, so you would have heard this phrase couple of times in your physics class if you paid attention. Um, so okay, for example, so this means that energy can neither be destroyed or created, but it can only be transformed to another form. For example, fans convert electrical energy into mechanical energy. So, when you switch on a fan, we provide the fan with electrical energy, and the fan converts the electrical energy into mechanical energy and turns on. Okay, and okay. When we eat food, we convert chemical energy into kinetic energy. So, when we eat food, food has chemical energy, and when it goes in our stomach and we utilize our body utilizes it, it converts it into kinetic energy. First of all, it converts into kinetic energy, and it's used by our cells in our body. When we roll a ball, we convert potential energy into kinetic energy. So when we roll a ball, the ball when it is in a state where it is not moving, has potential energy, and when we move it, it converts the potential energy into kinetic energy. So as you can also see in this picture, this is ice cream, very yummy, right? People love to eat it. Okay, so ice cream has chemical energy, and other foods also have. And when we eat it, we convert it into kinetic energy, right? And the second one, the light comes from the sun, so that is light energy. And the leaves of the plant utilize it with the help of carbon dioxide and water and minerals, and convert it into chemical energy. Okay. Second law of thermodynamics. This law states that energy in the form of heat only flows from regions of higher temperature to that of lower temperature to reach equilibrium. Okay. So as you can see, this law means that energy in the form of heat means heat energy. Heat energy only flows from regions of higher temperature to that of lower temperature to reach equilibrium. So, for example, when we sit in a hot room, our body produces sweat to cool down our body and emits the heat into the surroundings, which makes the surroundings hotter. When we sit in a hot room, obviously our body also becomes hot. So our body our body produces sweat to cool down our body. The sweat comes on our hands and feet, and it takes the heat energy from our body and moves it and throws it and gives it to the surrounding. Okay, so our body becomes cooler while the surrounding becomes hotter. So as you can also see in this picture, heat never moves from a cold object to a hot object. It is impossible. Okay, and as you can also see, this water has higher temperature. This has low temperature too, so heat moves from here to here, so that the temperature of both of them is equal. So, if the temperature of both of them is equal, then there will be no heat transfer. Okay, because they have reached an equilibrium. Third law of thermodynamics. So this law is a little difficult. This law states that the entropy of a perfect crystal is zero when the temperature of the crystal is absolute zero Kelvin. Okay, so this means first of all, entropy means that how much how much does do the particles in the in an object move. Okay, so as you can know, in solids particles move very less, so they are very less entropy. Okay, and in water we have water has a little more space, so it can arrange itself in a more random positions, so it has higher temperature, the higher entropy than solids. And gases have the highest entropy because the particles are so distant are so distant that they have a lot of space to move, and they can arrange in a lot of random formations. Okay, so entropy is sometimes called waste energy, i.e. the energy that is unable to do work, and since there is no heat energy whatsoever at absolute zero, there can be no waste energy. So first of all, crystal is are like are normal objects like table, chair, wood, iron, etc. Not glass or gel. Okay, that are other form of matter. Okay, another form of object. Okay, and Kelvin is another method of measuring temperature, another unit. Okay, and 0 Kelvin is around a range of minus 273 degrees Celsius. So it is very cool. Okay, and in this same point means that entropy is the energy that is unable to do work. Okay, and if there is no energy, then there is no entropy, obviously, right? So as at absolute zero it is, there is no energy whatsoever, so there is also no there is also no entropy. Okay, for example, the molecules within steam move freely and have high entropy the, because the molecules as steam is a gas, so the distance between the molecules is very great, so they have a large area to move freely, and so they have a high entropy. If one decreases the temperature below 100 degrees Celsius, the steam gets converted to water, where the movement of molecules is restricted, decreasing the entropy of water. Okay, so first of all, I forgot to tell something in first of thermodynamics. So you were thinking, how was energy created in the first place? Because if energy was created in the first place, then it will break the first law of thermodynamics. So scientists are trying to find a solution to this problem. Okay, so if so okay, if one decreases the temperature below 100 degrees Celsius, the steam gets converted to water, where the movement of molecules is restricted, decreasing the entropy of water. So if the temperature comes below 100 degrees Celsius, then the steam gets converted to water. Okay, that is 33 degree Fahrenheit, 36 degree Fahrenheit. Okay, that is not 36 degree Fahrenheit, sorry. The steam gets converted to water. Okay, because boiling point of water is 100 degrees Celsius, so the steam gets converted to water. So in water, as it is a liquid, it has lower entropy than gases. So uh, the movement of molecules is a little more restricted as compared to gases, decreasing the entropy of water. Okay, when water is further cooled below 0 degrees Celsius, it gets converted to solid ice. So as in this state, the movement of molecules is further restricted and the entropy of the system reduces more. So as solids have less entropy, are the movement of molecule in solid is a lot more restricted, as compared to liquids, the entropy of solids is much lower. As the temperature of the ice further reduces, the movement of the molecules in them are restricted further and the entropy of the substance goes on decreasing. So as we keep on decreasing the temperature of the ice, the movement of the molecules again is restricted further and the entropy of the substance goes on decreasing. When the ice is cooled to absolute zero, ideally the entropy should be zero, right? Because when the ice goes to absolute zero, there is no energy. So the entropy should also be there. So the entropy should also be zero. But in reality, it is impossible to cool any substance to absolute zero. Okay. So absolute zero is a very low temperature. The temperature of the whole universe is also uh, greater than absolute zero. So scientists in labs have reached about as close to absolute zero, but they missed it by 200ths of a Kelvin. So scientists were very close to reach absolute zero. Okay, as you can also see, if a highly ordered particle has more uh, um, a highly ordered particle increases in entropy, then it becomes more disordered. Just like if in liquids, when it increases in entropy, when the molecule of the liquid start going away from each other, then it becomes more disordered. So thank you for watching my video, and the information was courtesy was by Juice. So I will also give the links of the Byju's page from where I took the information, and I will also give some additional information. Thank you for watching my video, and please like, share and subscribe. Please like, share and subscribe. I will also give the link of the PPT in the description. So this was a little big video as compared to the last one. Last one was 10 minutes. This is about 18 minutes. So thank you. If you support my channel, I will keep doing the hard work and provide you with this information. This PPT took me about 1 hour, 1.5 hours. So thank you for supporting my channel, and thank you and bye. We will meet in the next video.